Advanced Math Lesson 32, Part C is inverse trig functions. I have started to fill this out for you. Cosine, we're going to start with. The cosine of each angle has only one value, so the cosine is a function. You know, the cosine function, we talk about the trig functions. It's a function. The domain is all angles. The range would be just from -1 to 1, including them. So -1 is less than or equal to y, which is less than or equal to 1. Okay, if it's a quadrantal angle, you're either getting 0, 1, or -1. And for all the other angles, you're doing a leg over the hypotenuse. It's going to be something less, where the absolute value is less than 1. So it'll never go below -1 or above +1. Okay, so is it 1 to 1? I'm already telling you here, no. And we're going to consider 60 degrees, 300 degrees, and 420 degrees. Okay, the cosine of 60, that's in the first quadrant here. Cosine is 1/2. 300 degrees gives us a 60-degree angle here in the fourth quadrant. So we have another 30, 60, 90 triangle. The cosine of that, 1/2. 420, you can go the whole way around here, that's 360. Another 60 degrees will give us the 420. So this is the same triangle we had over here. So same result. The cosine of that would be 1/2. And this is showing that there are at least, and there are an infinite number of them, but this we have shown 3 angles that have the same cosine. Therefore, it cannot be 1 to 1. If it were 1 to 1, there'd only be one angle for each of those values. Okay. You may recall from, just recently, we were talking about inverse functions. If a function is 1 to 1, then it has an inverse function. Cosine's not 1 to 1. It has an inverse, but the inverse is going to be a relation rather than a function. But we call the inverse of cosine inverse cosine. And there are a couple of different notations that we use for that. Both of these, inverse cosine of x or arc cosine of x, they're the same thing. That -1 is just a notation. It is not the same as like 1 over cosine of x. It's not the reciprocal. Okay, that is not an exponent. It's just the notation that is often used for inverse cosine. Okay, not an exponent. Each of these things means the angle which has cosine of it equals x. There should be a shorter way of saying that. Angle whose cosine is. That would have been shorter. Well, we'll do that later. Angle which has a cosine that equals whatever x is. So, inverse cosine of 1/2. That's saying what angle gives us a cosine that is 1/2. Well, we saw a few of them up here. So, inverse cosine of 1/2 could be 60 degrees. Could be 300 degrees. 420 degrees. We can keep on adding 360 to any angle we have on our list, and it's going to give us another one. Okay, there's an infinite number. So it's a relation. We can have these, pairs of numbers that match up, but it's not a function because there are many different y's that go with each of these x's. Okay, now it would be useful if we had a function that inverse cosine were a function. So in those cases, we restrict the numbers that, like the angles that we will give as results to these. We're going to restrict it for cosine to be 0 degrees to 180. 0 to 180. Inclusive. So I guess I'll just write it like that. So including 0 and 180. Okay, so that would just limit this list to one answer, which would then make it a function. Okay, some publishers, including the publisher of our book, uses the notation that you'll see down here. Okay, so you need to pay attention to detail. If lowercase letters are used, they're talking about the relation. That would be the whole big long list of answers. If capitals are used, then they're talking about the function where you're restricted to your answer being somewhere between 0 degrees and 180 degrees. And the reason it's 0 and 180, I'll just mention that. All students take calculus, you know. And so cosine is positive here, cosine is negative there. That takes care of all possible numbers for cosine, and so we're restricting the angles to just 0 to 180. That way there's no repeat, and it will be a function. If we went any further, then here are some more negative cosines that would have two answers for like negative 1/2. Would be 60, but also 240. And we don't want that. So we're restricting it to just those two quadrants. So again, pay attention to details. Lowercase, they want like a list of answers. And capital, which is often what it's going to be, will be the restricted one. It's actually a function because there's only one answer. Okay. Let's talk about some little examples here just to emphasize the difference between those notations. Okay. Inverse cosine of root 3 over 2. Okay, so the way I'm going to figure this out, I know for inverse cosine, I'm not even looking at quadrants 3 or 4, it's just 1 or 2. This number is positive, so I know it has to be in the first quadrant because cosine is negative in the second quadrant. Okay, and the cosine is root 3 over 2, which means the adjacent is root 3. And the hypotenuse is 2. So I recognize this is a special triangle. Root 3 is opposite the 60-degree angle, which means that's 30. 30 is opposite the 1. So the answer here is 30 degrees, but it's a little c. So I'm not restricted to that quadrant. Okay, all students take calculus. It's only positive also down here. So it could be a 30-degree angle in the fourth quadrant. Okay, so 360 minus 30, it could be 330. It could have been negative 30. I can keep adding 360. Let's just do that one more. 390, dot, dot, dot. I have an infinite number of answers to that. Now, same argument here, the root 3 over 2, but a capital C. This is the one that's restricted. And so that's only going to be 30 degrees. So I misspoke earlier when I said that here. This is lowercase, no restrictions. It can keep on going, actually in either direction. Here, just that. Capital means restrict it to between 0 and 180, and between 0 and 180, that's the only angle that gives us cosine that's positive root 3 over 2. Now, over here, we have a negative root 3 over 2. Lowercase a means it can be that big long list, but now it's negative. So it's going to be second and third quadrants. Right, because all students take calculus, negative here. And so adjacent is root 3, is our cosine. Hypotenuse is 2. And these are 1. So I have a 30-degree angle inside the triangle here. 180 minus 30 is 150. 180 plus 30 is 210. And then I can keep adding 360 or subtracting 360 to get more angles that have that. So if I add 360 to that, 510, and so on. This would be a dot, dot, dot. Okay, this one is restricted because capital A, and so we're only looking at quadrant 2, so it's just the 150 degrees. The answer had to be between 0 and 180, including 0 and 180, so it's just that. Okay, inverse sine. So first we talk about the sine function. The sine of each angle has just one value, so it is a function. Sine is a function. Okay, there's an equation for it. I used an x instead of a theta again. The domain is all angles, just like for the cosine. And the range also is from -1 to 1, including them. So all y such that -1 is less than or equal to y is less than or equal to 1. And later we're going to actually graph the sine and cosine functions. For now, we're not. But we'll get to that. It'll probably help you visualizing, but I think going through these examples should be sufficient to show sine also is not 1 to 1 for the same reason cosine isn't. Let's look at these angles. Okay, so the sine of 60 degrees, if that's 60, here's 1, 2, root 3. The sine is root 3 over 2. The sine of 300, okay, so there's a 60. Then this is 1, 2, root 3. And sine, I didn't mean to do that for this one. Oh well. Okay, so the sine would be negative root 3 over 2. That's what I have, so that's what we'll do. 420 will be enough to show that it's not 1 to 1. Okay, so for this one, 420 is the same as 60, so it's identical to this first one, so it's positive root 3 over 2 again. Okay, so that one I should have changed, but that's okay. Those two are enough to show that it's not 1 to 1. This should have been 120. 120 would have also been root 3 over 2. But not 1 to 1. And again, we have the same kind of notation for inverse sine. Looks like sine to the -1, but that's not an exponent. You read that inverse sine. That you can read inverse sine as well. It's the same thing, but it's also arc sine. And these notations mean angle whose sine is x, whatever x happens to be. Okay, and since it's not 1 to 1, the inverse isn't technically a function because we have, many different answers given one value. However, we're going to restrict it so that it would be a function because, again, it's very useful. And so for this one, it won't work to use 0 to 180. That we only have positive values for sine of anything between 0 and 180. It's either 0 or some positive number. So for this one, we're going to go from -90 to 90 inclusive. So including -90 and 90. Because again, all students take calculus. And see, if we went 0 to 180, they're all positive for sine. That wouldn't be helpful. We're missing half of them. So if we go right here, quadrants 1 and 4, values for sine are positive in the first, negative in the fourth. So that's going to be our restriction. Our answers for inverse sine will be between -90 and 90. Okay, down here is talking again about the lowercase and the capital. It's the same situation we had for cosine. So just pay attention to details for those as well. And then we move on and talk about tangent. Okay, tangent is also a function. Okay, and there's the equation. Now, this is a little bit different than sine and cosine because tangent, as I mentioned very recently again, tangent is the same as sine over cosine. And so anywhere cosine is equal to 0, this will be undefined. So it's actually not all angles. It's most angles. However, it can't be anywhere where cosine is 0. So that means it can't be 90 or 270 or keep adding 360 to those numbers. So basically it can't be an odd multiple of 90. And let's see if the book has a short, easy way of writing that particular thing. The domain. Okay, the domain is a set of all angles other than positive, negative. No, they have the list. I thought they did this more nicely. Okay, so all angles except positive or negative 90, positive or negative 270. Keep adding 360 to those. Positive or negative 450. I think that might be enough, ... There would be a concise way of doing that, but this is sufficient for now. We'll get into that more whenever we're graphing that much later. The range for this is also different than for sine and cosine. It's all reals. They can keep on going up or down infinitely. So I'll just put all reals. It is not one-to-one, just like the other ones aren't one-to-one. Here's an example. Hopefully I chose better this time. Oh, good. Okay, so 45 degrees is right there. 1 root 2. Tangent is 1. And 225, that would be down here. All students take calculus. It's positive here as well because we have a negative over a negative. And it's still a 1 root 2, so y equals 1. That demonstrates there's more than one angle to give you that particular value of 1. So it's not one-to-one. The notations for inverse tangent, no surprise there. Looks like tan to the negative 1, but it's the inverse tangent, arctangent, and these mean angle whose tangent is x, whatever x is. Okay. For the inverse tangent, we consider angles between. This is the same, almost the same as sine. We're going negative 90 to 90, but it cannot include negative 90 or 90 because of this. Right there. Okay, so between negative 90 and 90, exclusive, not inclusive. Not including negative 90 or 90. That won't really come up. But anyway. Okay, so these are the notations again. Capitals mean the function where it's restricted. Lowercase means we're not restricted, and we can have an infinite number of answers. All right. You're usually going to see capitals where we're restricted. Okay, so here's an example. Example 3 here. arcsine of root 2 over 2. All right, here's where it's going to be very helpful for you to remember what happens when we're rationalizing denominators. This is the same as that. Okay, because if I started out with 1 over root 2, if I take that times root 2 over root 2, I'm getting what you see here. So it's extremely helpful to you to recognize that, because this is a special triangle in disguise. Okay, so I'm going to rewrite this arcsine of 1 over root 2. So capital A, I'm restricted, I'm either in quadrant 1 or 4. It's positive, so it's going to be 1. So here's my triangle, and sine is opposite over hypotenuse. The opposite is 1, the hypotenuse is root 2, it's a 1, 1, root 2, which is a 45, 90, which means that angle is 45 degrees. It has been evaluated. That's it. Okay, here is another. This one also looks a little strange. Okay, this is the same, that argument that's in there, that's the same as this, which is also the same as that. Or, if you prefer, that. That'll probably be the most helpful. Okay, so this is the same as the arctangent of 1 over negative root 3. Okay, so again, it's very helpful to remember, if you notice that your argument has some numbers that look like they're from a special triangle, try writing it in a different form, and it might be easier for you to then recognize your triangle. This one's negative, and we're doing arctangent, inverse tangent. Okay, it has to be 1 or 4, because it's negative, it'll be in quadrant 4. Tangent is opposite over adjacent, so the opposite is 1. I put the negative in the wrong place. I should have left that out front. The opposite is 1, and the adjacent would be root 3. That can't be the negative because it's on the positive x. This is down. It's the negative. Okay. All right. So, what angle is this? 1, 2, root 3, opposite the 1. Inside here is a 30. Now, for arctangent, our answer is supposed to be between negative 90 and 90 degrees. This is negative 30 degrees. If you had said 330, 330 has the same terminal side. It would give you the same triangle here, but then you're not following the rules. For this, the answer has to be between negative 90 and 90, so we have to write it like this, negative 30 degrees. Okay, example 5. Alrighty, we start with the inside. We have arctangent, and we see it's negative. Okay, arctangent automatically says quadrants 1 or 4. Negative says quadrant 4. I make a triangle. Okay. Tangent is opposite over adjacent. So opposite is 3, adjacent is 5. That's the negative part. Okay. So we are supposed to find the cosine of whatever that angle is. I don't have to know what that angle is. I just need the cosine of it. This part right here is the angle whose tangent is negative 3/5. Okay, but our final answer won't be that angle. It's just the cosine of it. So here's the angle. I need the cosine. Cosine is adjacent over hypotenuse. I need the hypotenuse. Okay, so now we're doing Pythagorean theorem. So, a squared plus b squared equals c squared. I know it's negative, but we're still getting 9. So 9 plus, wow, almost root 15. 9 plus 25 equals c squared. So c is the square root of 34, which does not simplify. Okay, so this is root 34, and now cosine adjacent over hypotenuse. 5 over root 34, but we don't leave our answer with a radical in the denominator. So we do that. And we have to see if it reduces. This one doesn't. That's the answer. I kind of think these are fun. I hope you enjoy them. Okay, so next one, arc cosine. Okay. Capital A, we know we're somewhere in quadrant 1 or 2. This one's positive. Anytime they're positive, no matter what the function is, you're in quadrant 1. Okay. Cosine, that's adjacent over hypotenuse. So adjacent hypotenuse. So the parentheses part, that's asking for the angle whose cosine is 2/3. Well, it's whatever that is, but our final answer is just the sine of that. So we do not need to know what that angle is, just what's the opposite over hypotenuse. So we need the opposite. So we're doing Pythagorean theorem again. A squared plus b squared equals c squared. 2 squared plus b squared equals 3 squared. So 4 plus b squared equals 9. Subtracting 4, b is going to be the square root of 5. Okay, so sine, opposite over hypotenuse, root 5 over 3. All done. And I guess that's the end of your notes. Have fun.